The pervasive presence of plastic waste in the ocean highlights the urgent need for sustainable solutions. Transitioning from a throwaway culture is essential to mitigate environmental damage caused by plastic pollution. Sustainable packaging offers a viable alternative to reduce plastic waste and promote environmental responsibility. Advanced water filtration systems can effectively remove microplastics and other pollutants from marine environments. Embracing sustainable solutions is crucial for preserving marine ecosystems and ensuring a healthier planet. Refill systems in coastal markets reduce single-use plastic consumption. Durable materials like glass are utilized in refill systems to promote sustainability. Aluminum containers offer a lightweight and recyclable alternative in refill programs. Refill systems encourage the reuse of containers, minimizing environmental impact. Aluminum recycling involves remelting scrap aluminum, which requires only 5% of the energy used to produce new aluminum from ore. Recycling aluminum significantly reduces environmental impact, including decreased greenhouse gas emissions and reduced mining waste. The aluminum recycling process includes collection, sorting, cleaning, remelting, and fabrication into new products. Efficient aluminum recycling systems are crucial for conserving resources and promoting a circular economy. Recycled aluminum maintains the same properties as virgin aluminum, making it suitable for a wide range of applications without quality loss. Glass can be recycled repeatedly without any loss of purity or quality. The glass recycling process involves collecting, sorting, cleaning, crushing, and melting the glass. Cullet, or crushed glass, is melted and molded into new glass products. Designing for refill programs can significantly improve glass recycling rates. Take-back programs encourage consumers to return glass containers for recycling. Tika bottles feature a lightweight aluminum construction for durability and portability. Etched volume marks on Tika bottles provide precise measurement and usage tracking. Tika bottles facilitate app-based, barcodeless returns for simplified recycling processes. Silicone-free lids on Tika bottles ensure purity and eliminate potential contamination. Metal wire bales enhance the recyclability and functionality of Tika bottles. Tika bottles combine innovative design with sustainable materials for environmentally conscious hydration. Seaweed farms in Java, Indonesia cultivate seaweed for alginate and carrageenan extraction. Alginate and carrageenan, extracted from seaweed, are used to create seaweed films for packaging. The process involves pressing seaweed into clear, thin sheets. Seaweed films offer a sustainable alternative to traditional plastic packaging. The extraction of alginate and carrageenan requires specific processing techniques to ensure purity and quality. Seaweed farming contributes to local economies and provides sustainable livelihoods for coastal communities. Seaweed films possess inherent breathability, a key property for food packaging applications. The breathability of seaweed film helps maintain the softness of bread by regulating moisture levels. Seaweed film's breathability also keeps vegetables crisp by preventing excessive moisture buildup. Research is actively exploring the potential of seaweed films as biodegradable packaging alternatives. Seaweed films are being investigated for their suitability as edible packaging materials. Ocean Wrap is designed as a compostable packaging solution for bakery and produce items. The compostable nature of Ocean Wrap ensures environmentally friendly disposal. Ocean Wrap is suitable for branding with water-based inks. Water-based inks provide a sustainable and non-toxic printing solution. Ocean Wrap maintains the freshness and quality of packaged goods. The design of Ocean Wrap supports a circular economy by reducing plastic waste. Mycelium can be cultivated in makerspaces to create protective cushioning materials. Farmers supply corn husks and coconut coir as substrates for mycelium growth. Mycelium binds the substrate materials together, forming a solid protective structure. The resulting mycelium composite serves as a sustainable and biodegradable cushioning alternative. Mycelium, the vegetative part of a fungus, starts as a network of fine white filaments. Over time, these filaments expand and colonize the agricultural waste, forming a dense cottony structure. The mycelium digests the agricultural waste, breaking it down into simpler compounds. As the mycelium matures, it transforms the waste into a solid, shock-absorbing material. The resulting mycelium composite is a lightweight, biodegradable, and compostable insert. This process converts agricultural byproducts into sustainable packaging alternatives. Tika crates represent mycelium-based protective packaging solutions. Tika crates are designed for electronics, cosmetics, and gift boxes. The packaging provides a sustainable alternative to traditional materials. Tika crates are compatible with refill glass jars. The mycelium structure provides shock absorption and insulation. Tika crates offer a biodegradable and compostable packaging solution. Polyhydroxyalkanoates, PHAs, are biopolymers produced by microorganisms. PHAs can be molded into various shapes, such as spoons, offering a biodegradable alternative to traditional plastics. The process involves microbial fermentation, PHA extraction, and subsequent molding. PHA-based products offer a sustainable solution by reducing reliance on fossil fuels and minimizing environmental impact. PHAs are biodegradable polymers, capable of breaking down under specific environmental conditions. The biodegradability of PHAs can be effectively demonstrated in marine settings. PHA production faces challenges related to cost and scaling. Overcoming production hurdles is essential for widespread PHA adoption and environmental benefits. Certain bioplastics necessitate specific composting conditions to ensure proper decomposition. Without appropriate infrastructure, some bioplastics may not degrade effectively, leading to underperformance. Industrial composting facilities offer optimized environments for bioplastic degradation. Prioritizing reuse is more environmentally beneficial than relying solely on bioplastic disposal. A focus on durable, reusable products minimizes environmental impact compared to single-use bioplastics. Tika utensils are reusable travel cutlery designed for sustainability. The cutlery features repairable handle pins, extending the product's lifespan. Tika Utensils incorporates a take-back program for industrial composting. The utensils are made from PHA, a biodegradable and compostable material. Nanocellulose is processed to create strong, transparent barrier films. The stirring process ensures uniform dispersion of nanocellulose fibers. These barrier films exhibit enhanced mechanical strength and optical clarity. Nanocellulose films serve as effective barriers against gases and liquids. The resulting films have applications in packaging, electronics, and biomedical devices. Chitosan is extracted from shrimp shells through a grinding process. The extraction process isolates chitosan, a valuable biopolymer. Chitosan exhibits antimicrobial properties, inhibiting bacterial growth. The antimicrobial action of chitosan is due to its interaction with microbial cell membranes. Chitosan's properties make it useful in various applications, including food preservation and wound healing. The extraction and application of chitosan contribute to sustainable resource utilization. Cellulose and chitosan films function as biodegradable packaging materials. Chitosan films exhibit antimicrobial properties, inhibiting bacterial growth. Cellulose is a polysaccharide consisting of glucose monomers connected by beta-1, 4-glycosidic bonds. Chitosan is derived from chitin through deacetylation, increasing its solubility and bioactivity. The structural integrity of cellulose and chitosan films provides a barrier against external contaminants. Green Shield Wrap is a cellulose film designed to extend the freshness of leafy greens and mushrooms. The wrap utilizes a chitosan top coat to enhance its protective properties. Green Shield Wrap provides a sustainable alternative to petroplastic packaging. The cellulose film is derived from renewable resources. Chitosan, derived from crustacean shells, provides antimicrobial properties. A slow sand filter can be constructed using readily available materials like buckets, sand, and gravel. The filter is built by layering gravel and different grades of washed sand inside a container. The layers of sand and gravel act as a biological filter, removing impurities from the water. Slow sand filters provide a simple and effective method for water purification in resource-limited environments. Construction of a slow sand filter involves basic materials and simple assembly techniques. Water filtration involves the physical removal of impurities as water passes through layers of sand and gravel. The sand layer acts as a fine filter, removing small particles and sediment from the water. Gravel layers provide initial filtration, removing larger debris and allowing for better water flow. This natural filtration process clarifies water, making it safer for consumption by removing suspended solids. The layered structure of sand and gravel mimics natural aquifer filtration, providing a sustainable water purification method. Filtered water is collected at the base, ready for further treatment or direct use as drinking water. Ceramic candle filters, crafted from local clay, enhance water filtration capabilities. The porous structure of ceramic candle filters effectively removes impurities from water. Firing local clay transforms it into durable and effective ceramic water filters. These filters provide a sustainable and accessible solution for clean drinking water. The candle shape maximizes surface area, increasing the efficiency of the filtration process. Adding ceramic candle filters to water filtration systems improves water quality. Activated carbon absorbs organic contaminants through a process where these substances adhere to the carbon's surface. The high surface area of activated carbon facilitates extensive absorption of organic materials. Zeolites remove ammonium and certain metals from solutions via ion exchange. Ion exchange involves the replacement of ions within the zeolite structure with ammonium or metal ions from the surrounding solution. The selectivity of zeolites for specific ions depends on their pore size and charge density. Mineral filtration utilizes materials like quartz-sand to physically remove suspended solids from water. Quartz-sand acts as a mechanical barrier, preventing larger particles from passing through the filter bed. Zeolite minerals possess a porous crystalline structure that enhances filtration efficiency. The porous structure of zeolite allows for the absorption of smaller contaminants, improving water purity. Physical filtration with minerals is a cost-effective method for pre-treating water before further purification. Mineral filtration systems are widely used in water treatment plants to remove sediment and turbidity. The Crystal Clear Filter, Science Edition, utilizes a stacked filter cartridge design. Quartz sand acts as a primary filter, removing larger particulate matter from the water. Zeolite further refines the water by absorbing heavy metals and other contaminants. Activated carbon removes organic compounds and chlorine, improving taste and odor. The refillable stainless steel cartridge ensures durability and reduces plastic waste. Final disinfection is crucial for ensuring water safety. Boiling water effectively eliminates harmful pathogens. Chlorine disinfection neutralizes bacteria and viruses in water. Ultraviolet, UV, radiation deactivates microorganisms by damaging their DNA. Local guidelines provide specific disinfection recommendations. Adhering to disinfection protocols ensures safe drinking water for consumption. Drying preserves food by reducing moisture content, inhibiting microbial growth. Smoking preserves food through dehydration and the deposition of antimicrobial compounds. Salting inhibits bacterial growth by creating a hypertonic environment. Pickling preserves food using acidic solutions to inhibit microbial activity. Fermentation relies on beneficial microorganisms to produce acids and alcohols, inhibiting spoilage. These ancient preservation methods extend shelf life and maintain food safety. Drying and smoking are effective food preservation techniques. Roman dried fruits demonstrate the historical application of drying for preservation. West African smoked fish illustrates the use of smoking as a traditional preservation method. Drying reduces water activity, inhibiting microbial growth and enzymatic spoilage. Smoking imparts antimicrobial compounds and dehydrates food, extending shelf life. Salting and pickling are widespread methods of food preservation. Mesopotamian vinegars represent an early example of pickling techniques. Global brines showcase the diverse applications of salting for food preservation. Salting inhibits microbial growth by reducing water activity in food. Pickling uses acidic solutions to prevent spoilage and enhance flavor. Both salting and pickling extend the shelf life of perishable foods. Fermentation is a preservation technique applied to various foods, including cassava. Dairy products like yogurt and cheese benefit from fermentation, enhancing flavor and shelf life. Vegetables such as cabbage and cucumbers are commonly fermented to produce sauerkraut and pickles. Fermentation is one of humanity's oldest methods of food preservation, predating modern refrigeration. Early cooling methods utilized evaporation, such as the Zeer-pot, to lower temperatures. Ice houses stored ice collected in winter to provide cooling throughout the year. Ice boxes used blocks of ice to keep food and drinks cool. Mechanical refrigeration enabled the development of modern refrigerators and freezers. Freezing techniques preserve food for extended periods by inhibiting microbial growth. Modern freezing technologies range from household freezers to industrial flash freezing. Pantry keep is a breathable ceramic crock designed for optimal food preservation. The integrated salt brine moat creates a barrier against pests and helps maintain ideal humidity for pickled items. A woven reed drying screen allows for proper air circulation, preventing mold and extending the shelf life of produce. The countertop evaporative cooler insert further enhances preservation by lowering the internal temperature of the pantry keep. Aluminum is highly suitable for long life and refill loops due to its excellent durability and resistance to corrosion. A significant advantage of aluminum is its high recycled content, reducing the need for primary production. Recycling aluminum requires significantly less energy compared to producing it from raw materials. The energy savings from aluminum recycling contribute to a lower environmental footprint and reduced greenhouse gas emissions. Aluminum's properties make it an economically and environmentally sustainable material for packaging and other applications. Glass is an endlessly recyclable material, contributing to sustainable resource management. The weight of glass can increase transportation costs and carbon footprint. Designing for local recycling loops can mitigate the environmental impact of glass weight. Local recycling loops reduce transportation distances, minimizing fuel consumption and emissions. Efficient local recycling systems enhance the economic viability of glass as a sustainable material. Prioritizing local recycling loops maximizes the environmental benefits of glass. Mycelium can be utilized as an effective compostable cushion material. Mycelium's natural growth process makes it a sustainable alternative to synthetic cushioning materials. Mycelium-based cushioning offers excellent shock absorption and protective capabilities. After use, mycelium cushioning can be composted, returning nutrients to the soil. Seaweed films can be utilized as compostable wraps. These seaweed wraps offer an environmentally friendly alternative to traditional plastic packaging. Seaweed-based packaging contributes to reducing plastic waste and promoting sustainable practices. The compostable nature of seaweed films allows for natural decomposition, enriching the soil. Seaweed wraps maintain food freshness while minimizing environmental impact. Cellulose and chitosan wraps represent compostable packaging alternatives. Cellulose and chitosan are derived from renewable resources, offering a sustainable material option. The compostable nature of cellulose, chitosan reduces environmental impact compared to traditional plastics. Cellulose, chitosan wraps maintain product freshness while supporting environmental responsibility. Polyhydroxyalkanoates, PHAs, are biopolymers that present a promising alternative to conventional plastics. PHA's biodegradability is conditional and depends on specific composting environments. Life cycle assessment (LCA) is essential to fully evaluate the environmental impact of PHA production and disposal. Despite its potential, PHA's composting behavior and LCA results require careful consideration for sustainable applications. Activated carbon is a highly effective filtration material due to its porous structure. The extensive surface area of activated carbon allows for significant adsorption of impurities. Activated carbon filtration is widely used in water purification and air treatment applications. The effectiveness of activated carbon is supported by scientific evidence and practical serviceability. Zeolites are aluminosilicate minerals with a porous structure, enabling them to act as effective filters. The porous network of zeolites selectively traps contaminants based on size and charge. Zeolite filtration is supported by extensive evidence of its effectiveness in removing impurities from water. Zeolites are serviceable in a variety of filtration applications, from industrial wastewater treatment to household water purification. The evidence-based and serviceable nature of zeolites makes them a valuable material in filtration technologies. Ceramic materials are utilized in filtration processes due to their inherent properties. The porous structure of ceramics allows for the effective removal of particulate matter from liquids and gases. Ceramic filters demonstrate high thermal and chemical resistance, ensuring reliable performance in harsh environments. The durability and inertness of ceramic materials contribute to the extended lifespan of filtration systems. Ceramic filtration systems are evidence-based solutions for water purification, air quality control, and industrial processing. Slow sand filtration is an evidence-based water purification method. Slow sand filters are serviceable and reliable for water treatment. The sand bed in slow sand filtration acts as a biological filter. Slow sand filtration effectively removes particulate matter and pathogens from water. Slow sand filtration provides a sustainable and cost-effective water purification solution. Tika's booth showcases a closed-loop kit at the Harbor Festival. The closed-loop kit promotes sustainability by minimizing waste and maximizing resource utilization. The kit includes components designed for reuse, recycling, and composting, reducing environmental impact. Informational posters explain the benefits of closed-loop systems and provide instructions for using the kit. The Harbor Festival provides a platform for promoting sustainable practices and educating the public. By adopting closed-loop principles, individuals and communities can contribute to a more sustainable future. Aluminum pantry tins are displayed as refillable containers. Glass spice vials with deposit rings promote sustainable packaging. The display showcases reusable containers for pantry and spice storage. Deposit rings encourage the return and reuse of glass spice vials. Mycelium inserts provide a sustainable alternative to traditional plastic packaging. Seaweed wraps offer a biodegradable and compostable packaging solution. Cellulose wraps, derived from plant fibers, present a renewable and eco-friendly packaging option. The combination of mycelium, seaweed, and cellulose creates a fully plastic-free packaging system. These materials offer biodegradable and compostable properties, reducing environmental impact. The stainless counter unit features a multi-stage filtration system. The filtration stack consists of sand, zeolite, carbon, and ceramic layers. Sand acts as a primary filter, removing larger particles from the water. Zeolite further refines the water by absorbing smaller impurities. Carbon removes organic compounds and chlorine, improving taste and odor. Ceramic provides a final filtration barrier, removing bacteria and pathogens. Pantry Keep offers specialized crocks designed for efficient and safe pickling processes. Pantry Keep drying racks facilitate the natural dehydration of herbs, fruits, and vegetables. Pantry Keep evaporative coolers provide a simple, energy-efficient method for cooling food storage areas. The Pantry Keep product line promotes sustainable food preservation and storage techniques. Families share personal stories during the Harbor Festival. Festival attendees refill jars with various types of pickles. The Harbor Festival offers a tasting experience of global pickles. Community interaction is fostered through shared culinary experiences at the Harbor Festival. Tika Refill offers aluminum bottles and tins designed for product refills. The bottles and tins come in multiple sizes to accommodate diverse product volumes. Each container features a threaded metal cap for secure closure and easy refilling. Tika Refill incorporates an app-track deposit system to encourage reuse. The deposit system incentivizes customers to return empty containers for a refund, promoting sustainability. Tika Ocean Wrap is a seaweed-based sheet roll designed for produce and bakery applications. The seaweed-based composition provides an eco-friendly alternative to traditional plastic wraps. Ocean Wrap sheets maintain product freshness while offering a biodegradable packaging solution. The sheet rolls are versatile for wrapping various sizes and shapes of produce and bakery items. Tika Ocean Wrap provides a sustainable and functional packaging option for food products. Tika Green Shield is a cellulose and chitosan-based antimicrobial wrap designed for short shelf-life foods. The wrap extends the shelf life of perishable foods by inhibiting microbial growth. Cellulose and chitosan provide a natural and biodegradable barrier against spoilage. The antimicrobial properties of the wrap reduce food waste and maintain product quality. Tika Green Shield offers a sustainable packaging solution for the food industry. Tika crates utilize mycelium cushioning for the safe shipment of fragile goods. Mycelium acts as a natural biodegradable shock absorber, protecting items during transit. Tika crates are specifically designed to protect fragile items from damage during shipping. The unique structure of mycelium provides excellent cushioning and insulation properties. Tika crates offer a sustainable and environmentally friendly alternative to traditional packaging materials. The production of Tika crates involves growing mycelium around a mold, resulting in a custom-fit protective structure. Tika Crystal Clear is a countertop gravity filter, employing multiple stages for water purification. The filter incorporates sand, zeolite, carbon, and ceramic stages to remove impurities from water. Replaceable mineral cartridges enhance water quality and maintain optimal performance. The user guide emphasizes final disinfection to ensure water safety. Tika Pantry Keep offers specialized pickling crocks for preserving foods. Drying mats are available to aid in the dehydration and preservation of various ingredients. The clay evaporative cooler insert helps maintain optimal temperature and humidity. Pickling crocks facilitate anaerobic fermentation, essential for traditional pickling. Drying mats promote even moisture removal, preventing mold and spoilage. Clay evaporative cooling lowers ambient temperature, extending the shelf life of produce. System design should prioritize reuse mechanisms, such as refill and deposit programs, to minimize waste generation. Prioritizing reuse reduces reliance on single-use items and the need for extensive composting infrastructure. Refill and deposit systems encourage consumer participation and responsibility in waste reduction efforts. Compostable materials should be considered after reuse options are exhausted in the system design. Monotype material design simplifie end-of-life recycling process. Using a single material, such as metal or glass, reduces contamination during recycling. Mono-material products can be efficiently sorted and reprocessed into new raw materials. This approach enhances material recovery and minimizes waste sent to landfills. Publishing an Open Life Cycle Assessment (LCA) summary is crucial for transparency and accessibility. An open LCA summary facilitates better understanding and adoption of sustainable practices. A Where It Works map enhances the LCA summary by providing location-specific information. The Where It Works map indicates the availability of infrastructure, such as composting facilities for PHA. Open LCA summaries and Where It Works maps promote informed decision-making and collaboration. This integrated approach supports the transition towards a more circular and sustainable economy. Quartz-sand serves as a primary filtration medium, effectively removing larger particulate matter from water. Zeolite's unique crystalline structure enables selective adsorption of specific contaminants, including ammonia and heavy metals. Ceramic media provides a large surface area for beneficial bacteria to colonize, facilitating biological filtration and nutrient removal. Activated carbon effectively adsorbs organic compounds, chlorine, and other taste and odor-causing substances from water. Filtration must always be paired with a final disinfection step to eliminate microbes. Boiling is an effective disinfection method, using heat to kill microorganisms. Chlorine disinfection involves adding chlorine to water to neutralize pathogens. UV disinfection uses ultraviolet light to inactivate microorganisms. Solar SODIS, solar water disinfection, utilizes sunlight to disinfect water in clear plastic bottles. Combining filtration with disinfection ensures safer drinking water by removing and neutralizing harmful microbes. Porous ceramic beads are engineered to incorporate internal zeolite structures. The internal zeolite facilitates ion exchange for water purification. Biochar or activated carbon components are integrated to adsorb organic contaminants. A ketosand surface layer provides antimicrobial properties to the hybrid media. Beads are designed to be easily interchangeable within a stainless steel cage. The stainless steel cage functions as a tea infuser style container for the beads. The snapping mechanism allows for quick and secure bead swaps within the cage. This hybrid media assembly facilitates customization and reconfiguration. The seaweed cellulose bilayer wrap features an alginate outer layer for oxygen and moisture barrier. The inner layer of the wrap consists of nanocellulose, providing strength to the structure. Water-based heat-sealable seams ensure the wrap can be securely sealed. Dissolvable labels can be integrated into the wrap for product information and branding. The bilayer structure combines barrier properties and structural integrity for sustainable packaging. Mycelium corner locks offer a sustainable alternative to foam packaging for shipping cartons. The interlocking L-keys design provides secure corner protection during shipping. Standardized dimensions allow the mycelium locks to fit various shipping carton sizes. After use, the mycelium locks can be composted, enabling a flat pack return and reducing waste. App-encoded aluminum canisters feature scratch-proof laser marks for durable identification and tracking. Deposit return triggers an automated refurbish and redeploy loop, optimizing resource utilization. The automated system reduces waste and energy consumption through efficient material reuse. This deposit smart pantry system promotes sustainability by minimizing environmental impact. The Pantry Keep Evap Cooler insert is a modular porous ceramic sleeve. This sleeve nests inside a common clay pot. The combination creates a household evaporative cooler for produce. Evaporative cooling lowers the temperature inside the pot, preserving produce longer. The porous ceramic allows water to seep through and evaporate, drawing heat away from the contents. Zeolites possess a porous structure at the microscopic level. The porous structure of zeolites enables ion exchange capabilities. Ion exchange occurs within the zeolite's interconnected channels and cavities. Zeolite's framework structure is composed of repeating tetrahedral units. The size and shape of zeolite pores determine their selectivity for different ions. Activated carbon is a material with a high surface area, riddled with microscopic pores. Organic molecules are adsorbed onto the surface of activated carbon through physical attraction. The adsorption process traps organic molecules within the pores, effectively removing them from the surrounding environment. This adsorption mechanism enables activated carbon to purify liquids and gases by removing impurities. The effectiveness of activated carbon depends on its surface area, pore size distribution, and the properties of the adsorbate. Chitosan exhibits antimicrobial properties by disrupting microbial cell walls. The disruption of the cell wall leads to leakage of intracellular components. Chitosan's positive charge interacts with the negatively charged microbial cell membrane. This interaction causes structural damage and functional impairment of the cell membrane. Ultimately, chitosan induces cell death by compromising the integrity of the microbial cell. Seaweed film begins as a solid, flexible material. Initial exposure to compost introduces moisture and microbial activity. Over time, the seaweed film gradually breaks down into smaller fragments. Decomposition results in the seaweed film integrating into the compost. The final stage sees the seaweed film fully assimilated, enriching the compost. Mycelium packaging is designed to decompose naturally in a home compost environment. The decomposition process involves the breakdown of mycelium by microorganisms present in the compost. Time-lapse visualization shows the mycelium packaging gradually breaking down over a period of several weeks. Nutrients from the decomposing mycelium are released back into the compost, enriching the soil. The decomposition process of mycelium packaging is environmentally friendly and sustainable. Compared to traditional packaging, mycelium offers a biodegradable alternative that reduces waste. Returned aluminum canisters undergo an initial inspection to assess their condition and sort them by alloy type. Canisters are cleaned to remove labels, residue, and contaminants, ensuring a pure aluminum source for the melting process. Damaged canisters are repaired or shredded into smaller pieces to prepare them for melting. The prepared aluminum is melted in a furnace to create molten aluminum, ready for casting into new products. Refurbished aluminum canisters are redeployed, completing the recycling loop and reducing the need for new aluminum production. The initial step involves ensuring the Tika crystal clear filter is correctly installed and securely connected to the designated system. Proper usage requires adjusting the filter settings according to the specific water quality parameters and desired output clarity. Regular maintenance includes periodic backwashing to remove accumulated sediment and prevent clogging, ensuring optimal filter performance. Long-term maintenance involves replacing the filter cartridge at recommended intervals to maintain filtration efficiency and water purity. Slow sand filters are a simple and effective method for water purification, utilizing a biological process to remove pathogens and impurities. The filter's biological layer, or Schmutzdeck, is crucial for removing organic matter and microorganisms from the water. Construction of a slow sand filter involves layering gravel and sand within a container, ensuring proper drainage and filtration. Regular maintenance, such as removing the top layer of sand, is necessary to ensure the filter's continued effectiveness. Pickling is a method of preserving food through anaerobic fermentation in brine or immersion in vinegar. Different cultures around the world have developed unique pickling techniques and flavor profiles. Pickling preserves food by creating an environment inhospitable to spoilage microorganisms. The acidity of the pickling liquid inhibits the growth of many bacteria and fungi. Pickling techniques represent a form of cultural heritage passed down through generations. Tika products contribute to a sustainable future by reducing waste. Tika promotes reuse to minimize environmental impact. Tika's vision includes ensuring access to clean water. Sustainable practices are integral to Tika's product development and distribution. Tika envisions a future where product design actively supports environmental stewardship.